Hello students, in this video I will show you what happens to a binomial distribution when we increase the number of trials and keep the probability of success the same. We have this experiment where the probability of success is 20% and the number of trials is 20. I graphed it and it gave me this shape. Now I'm going to increase the number of trials and see what happens to the shape. So from 20 I'm going to increase it to 50, and then from 50 I'm going to increase it to 100. Notice what happens to the shape of the binomial distribution. I'm going to increase it to 500, and then I'm going to increase that to 1000. Notice how the shape of the binomial distribution turned into bell-shaped when we increase the number of trials. For a fixed p, which is probability of success, as the number of trials n in a binomial experiment increases, the probability distribution of the random variable x becomes bell-shaped. As a rule of thumb, if n times p times 1 minus p is greater than or equal to 10, the probability distribution will be approximately bell-shaped, meaning that we can treat it as a normal distribution. Use the empirical rule to identify unusual observations in the binomial experiment. The empirical rule states that in a bell-shaped distribution, about 95% of the observations lie within 2 standard deviations of the mean. Anything beyond 2 standard deviations or below 2 standard deviations is considered unusual. We want to use the empirical rule to identify unusual observations, meaning we want to determine the 95% cutoff. That is the mean minus 2 standard deviations and the mean plus 2 standard deviations. Any observations outside of that interval is considered unusual. Let's look at this example. According to Experian Automotive, 35% of all car-owning households have 3 or more cars. A researcher believes that this percentage is higher than the percentage reported by Experian Automotive. He conducts a simple random sample of 400 car-owning households and found that 162 had 3 or more cars. Is this result unusual? So to find that, we're going to use the empirical rule, and hopefully you still remember how to use the empirical rule. We're going to compute the 95% of data in the middle, and anything beyond the 2 standard deviations or below the 2 standard deviations is going to be unusual. So we compute the mean and the standard deviation in the same manner that we did for this example previously, using the formulas provided, and then we compute the mean minus 2 standard deviations to determine the cutoff for the middle 95%. And that will give me the value 120.9 for the lower cutoff and 159.1 for the top cutoff. So 95% of the data lies between the two numbers 120.9, 159.1. So the result that the researcher got in the experiment is considered unusual because it is beyond the, you could say, the upper limit or the upper fence of the data. It's in the 5% instead of in the 95% of the data. This is a simple example on when can we use the empirical rule, because the number of trials is big and we can consider the binomial distribution to be a normal distribution and we can apply the empirical rule to it. So I hope this video helped you, and I will see you in a different one.